Hello, today we are going to be talking about trees, a new data structure very similar to linked lists, except that elements are able to be added in multiple hierarchies with many next elements per node. So far, we've been looking at linked lists in which there's a sequential order of nodes, with each node having a next node and a previous node. With trees, we instead have a sequential order of nodes, but each node can split off to have many next nodes. Whereas with linked lists, the next node was called next and the previous node called previous. With trees, the previous node is called the parent and it has a child relationship going forward. So with trees, child is equal to next and parent is equal to previous. Additionally, we should be used to a linked list having a head element, whereas with trees, we have a root element. Otherwise, they're pretty much the same thing. Just like with a linked list, when we have a null root, we have an empty tree. General trees have no restrictions on the number of elements or the number of children nodes that each node could have. That means that each node could have 5 children, 100 children, 1 child, or no children. All of this is okay. A binary tree can only have 0, 1, or 2 children per node. This means that binary trees generally look something like this. We cannot have any node which has more than 2 children. With a binary tree, the children have specific names. There is a left child and a right child. Technically, when a node has one child, that child could either be on the left or right, but let's prefer that a one-child node will have its child on the left side. Now, let's talk about navigating a binary tree. Now, just like with a linked list, we always start at the top or the root node. Now, this root node will have 2 options. We could either go down to the left side or the right side. Now, technically, this node has a parent, but on the root node and only the root node, this parent is equal to null, so we can't go up there. So basically, we can move current to root's right child. Once there, we only have one option, which is either the left, or actually, could go back up through the parent pointer. Through traversing the parent to go up, or the left or right to go down, we can get to any node in the tree. Now, how can we use this to traverse a binary tree? There are 3 major algorithms. There is Preorder, Inorder, and Postorder Traversal Algorithms. Each one will produce a different display output. Let's take a look at an example binary tree. The algorithm for preorder traversal is to take a look at the current node. If it's not null, then visit, which means basically take a look at it or display it or do whatever we want to do with the current node. Recursively visit or traverse its left node, then recursively traverse its right node. So our first node, 1 here, is not null. So we're going to visit it, and this might print out 1. The next thing we're going to do is traverse its left child. This is also not null, and so we're going to visit it. This will print out 2. Then we're going to traverse its left child. We'll get to 3. This is not null, so we're going to visit it, and we're going to try to traverse its left child, but that's going to be null. We're then going to try to traverse its right child. That's also going to be null, and so we're going to move back up the recursive stack back to 2. We've just visited its left child, and now we can proceed to its right child of 4. We're then going to try to visit each of its 2 children, but then finish the recursion. Now we're all the way back to 1. We've finished traversing all of its left children, and now we proceed to the right children. We're going to visit 5, who's going to try to visit its left child, which will be 6. 6 has no children. We're then going to traverse 5's right child, which is 7. That gives us the preorder traversal of this tree. With Inorder traversal, we follow a slightly different algorithm. If the current node is not null, we're going to traverse the left, then we're going to visit, then we're going to traverse the right. So we start at the root, but then we immediately go to the left. We then are at 2, and this is not null as well. So we go to the left. This causes us to get to 3, which has no children. It tries to traverse its left child, which is null. It stops, which allows 3's function to get to visit, causing 3 to be printed. Next, we try to traverse 3's right child, but there's nothing there. We then are back to 2, which causes 2 to get printed because we've already visited its left. We then traverse its right subtree, causing us To get to 4, we try to traverse its left, but that's null. We then visit 4, try to traverse its right, but there's nothing there as well. 4 is now finished, makes 2 now finished. We have then traversed 1's left subtree, so we are now on its visit step, causing us to print 1. We then are ready to traverse its right subtree. This causes us to reach 5, but first we have to traverse its left subtree. We therefore get to 6. 6 has no left subtree, causing us to get to visit. Try to traverse 6's right subtree. That finishes off 6. We've now traversed 5's left subtree, causing us to print 5, and then go to its right subtree. We try to traverse 7's left subtree. That's null, which causes us to get to the visit step for 7. We then try to traverse its right subtree, and we have now finished the entire tree. With post-order traversal, we again have a very similar but slightly different algorithm. We first visit the left subtree, then the right subtree, then we visit, right? Let's see this in action. So we're going to start at 1. That's going to cause us to visit its left subtree. We're going to get to 2. We're going to visit its left subtree. We're going to try to visit its left subtree. Nothing there. Its right subtree. Nothing there. Causing us to be able to visit 3. Now we've traversed 2's left subtree, but now we have to traverse its right subtree. So we get to 4, nothing on its left, nothing on its right, so we're able to visit 4. We then have visited both 3 and 4, which is 2's left and right subtrees, allowing us to print 2. We now have visited 1's left subtree, causing us to go to 5. We then will visit 6, try to visit its subtrees, nothing there. We'll get to 6. We've now visited 5's left subtree. We're then going to go to 7, visit its subtrees, nothing there, so we'll be able to visit it right away. We've then visited both 5's left and right subtrees, allowing us to visit 5. We then have visited 1's left and right subtrees, allowing us to visit 1. And those are the 3 types of traversal algorithms. We have post-order, in-order, and pre-order. This has been a brief overview on trees. For a lot more information and some implementation details, be sure to visit the reading. Thanks for watching.